The development of the gas turbojet engine and its revolutionary first combat application in the Messerschmitt Me 262 Schwalbe Swallow constitutes, arguably, the single most profound and disruptive technological leap in the entire history of aviation during World War II. For over 4 decades, the constraints of aircraft design had been absolutely bound by the physical, unyielding limits of the piston engine and the propeller mechanism, a setup that prevented sustained, efficient flight speeds much beyond 450 miles per hour, imposing a technological ceiling. The turbojet engine, however, fundamentally changed the physics of flight. It possessed no propeller, relying instead on the principle of generating forward thrust by violently expelling a high-velocity jet of hot, expanding gas. This innovation completely shattered the previous speed barrier. By the early 1940s, highly focused German engineers had achieved an engineering revolution, successfully developing a practical, powerful, and ready for mass production jet engine. The Me 262, the ultimate culmination of this ambitious research effort, offered a terrifying, definitive glimpse into the immediate future of air power, achieving operational speeds exceeding 560 mph, 900 km/h, a velocity over 100 mph faster than any conventional Allied fighter, effectively rendering the entire world's fleet of piston-driven aircraft obsolete overnight. While the technical concept of jet propulsion was not an exclusive German domain, with both Britain, the Gloster E-2839, and Italy, the Caproni Campini N1, having operational prototypes successfully flying by 1941, German research, fueled by the intense, existential demands of the Nazi war machine, was both technologically broader, more aggressively pursued, and better funded. The key visionary figures driving this development were engineers Hans von Ohain and Anselm Franz. Ohain successfully developed the first functional centrifugal flow jet engine, which powered the Heinkel He 178, achieving the world's first jet flight in August 1939. However, this design was quickly surpassed by the work of Franz at the Junkers Company, who perfected the UMO 004 axial flow turbojet. This engine was a masterstroke of mass-producible industrial design, structurally simpler, strategically better suited for sustained high-speed flight, and offering superior fuel efficiency at high altitude. The JUMO 004 became the undisputed power plant of the ME 262 and established the foundational architectural template for nearly all subsequent generations of jet engines worldwide. The Messerschmitt Aircraft Company initiated the design and development work on the definitive jet airframe, designated Project P-1065, as early as 1938, demonstrating extraordinary foresight. The entire aircraft structure was meticulously designed specifically to integrate and accommodate the revolutionary power of the twin JUMO 004 engines. The airframe incorporated several advanced, cutting-edge characteristics that defined its speed, notably the use of swept wings. Crucially, chief designer Willy Messerschmitt initially applied a slight, noticeable 18.5-degree sweep to the wings, not primarily for the aerodynamic benefits at high speed. The full scientific benefit of sweeping was not yet completely understood, but rather to physically relocate the aircraft's center of gravity, CG, rearward, compensating for the necessary forward placement and heavy weight of the newly installed jet engines. The Me 262 prototype, which initially required a piston engine fitted in the nose for taxiing and stability, finally flew powered solely by its twin jet engines on July 18, 1942, a date that stands as a truly momentous, unheralded occasion in global aviation history. Despite achieving such staggering, world-beating performance in test flights, the Me 262 program was plagued by a series of catastrophic and nearly crippling developmental and political delays that ultimately sealed its fate. The single greatest technical hurdle was the chronic, often catastrophic unreliability and tragically short operational lifespan of the JUMO 004 engine, which frequently lasted only 10 to 25 hours of operational use before requiring a complete overhaul or replacement. a limitation stemming from acute material shortages and internal design flaws. Compounding this technical crisis, the project was severely and perhaps fatally hampered by Adolf Hitler's disastrous, politically driven interference. Obsessed with immediate retaliation, Hitler viewed the jet primarily as a high-speed blitz bomber, a fast attack bomber designed for swift, low-level strikes, rather than the strategic interceptor fighter its brilliant designers and experienced test pilots knew it absolutely needed to be. This political edict forced Messerschmitt to waste critical, irreplaceable months modifying the pristine airframe for external bomb racks, a tactical detour that ultimately delayed the jet's crucial, effective deployment as a dedicated fighter by well over an entire year. The operational performance of the finished aircraft was nothing short of a revolution. Powered by its two formidable Jumo 004B engines, the Me-262 could easily attain a maximum speed of nearly 560 mph, 900 km/h, an unheard-of velocity that neither the Allied P-51 Mustang nor the Spitfire could even dream of approaching. This profound speed advantage offered the jet pilots almost complete, instantaneous immunity from interception. To translate this speed advantage into lethal combat power, the Me-262 was armed with four devastating 30mm Mk108 cannons mounted in the nose, a powerful, high-caliber armament capable of shattering an American heavy bomber with just a few successful, well-aimed hits. Furthermore, in the final desperate months of the war, it pioneered the use of the R-4M unguided air-to-air rockets, which could effectively saturate a dense bomber formation from a safe distance beyond the range of the bomber's defensive machine guns, instantly making it the most lethal and technologically advanced aerial weapon system deployed during the entire conflict. The operational debut of the first Me-262 fighter squadrons began in late 1944, and the jets immediately proved to be devastatingly effective in their designed role as high-speed interceptors. The tactical profile was simple and terrifying. They would execute rapid vertical climbs to altitude, accelerate to maximum speed, tear through the sprawling formations of American B-17s and B-24s, inflict severe, crippling damage with their heavy cannons, and then disappear back into the sky before the escorting P-51 Mustangs could even close the distance. The Me-262 pilots consciously employed a classical hit-and-run tactic, knowing that their immense speed advantage meant that engaging in a conventional, wasteful dogfight was completely unnecessary. This massive, unprecedented speed differential instantly created a state of deep operational fear and strategic concern among every level of Allied air command, threatening the success of the entire strategic bombing campaign. Despite its seemingly insurmountable speed advantage, the Me-262 possessed several critical, exploitable operational weaknesses. Its acceleration at lower altitudes was notoriously slow, and its engines were unresponsive, making it dangerously vulnerable during the phases of takeoff and landing. Furthermore, because the early jet engines required extremely high revolutions to produce meaningful thrust, the Me-262's cockpit was an inherently complex and demanding workplace, requiring the pilot to maintain constant, delicate monitoring and precise throttle adjustments, especially during maneuvering or emergency situations. Allied pilots, highly skilled and quick to recognize these exploitable vulnerabilities, quickly adopted a strategy of deliberately loitering near the known German jet airfields, patiently waiting for the jets to approach for landing when their speed was at its lowest and their pilots were completely preoccupied with the delicate engine management required to maintain safe flight. The Allies' concerted strategic response to the existential Me-262 threat was a fundamental tactical shift, the introduction of dedicated jet hunter missions. P-51 Mustang fighter groups were given a new dual mandate, not only to provide protective escort for the bombers, but also to actively seek out and destroy the Me-262s wherever possible. They systematically targeted the jets, either on the ground, destroying them within their heavily hardened aircraft shelters, or more effectively, during their single most vulnerable operational phase, their final approach and landing patterns to their home bases. Additionally, General George S. Patton's rapidly advancing ground troops played an equally key role in the final destruction of the German jet forces by quickly overrunning their forward airfields, denying the Luftwaffe the crucial forward operating bases they needed to project jet power effectively. One of the most immediate, critical, and unsolvable problems confronting the entire Me-262 program was the absolute lack of reliable, accessible fuel. The jet engines required large quantities of high-octane, specialized kerosene-based fuel, a resource that Germany was desperately and chronically short of by late 1944 due to the relentless, successful destruction of all key synthetic oil plants by the massive Allied bombing campaign. This constant, crippling fuel crisis severely and directly limited the number of operational sorties the Me-262 squadrons could fly. Alarmingly, often a single sortie flown by a technologically advanced Me-262 meant a corresponding critical shortage in fuel allocated for the piston-engined interceptors, or even for the desperate armored divisions on the Eastern Front, creating a vicious, destructive logistical competition for all remaining petroleum resources. The logistical nightmare extended with equal severity to the actual manufacture of the high-performance Jumo 004 engine. It required extremely scarce, high-grade nickel and chrome alloys to fabricate the turbine blades and combustion chambers necessary to withstand the immense internal operating temperatures generated by jet combustion. As the war rapidly turned against the Reich, these crucial materials became virtually unobtainable. German engineers were reluctantly forced to substitute inferior, local alloys, and eventually even resorted to using experimental ceramics for some internal components, which drastically reduced the vital engine reliability and operational life, contributing heavily to the Me-262's extraordinarily high attrition rate and chronic maintenance backlog. Despite the overwhelming chronic shortages of fuel, material, and manpower, German industry managed to produce an approximate total of 1,430 Me-262 airframes over the course of the war. However, a much smaller, disappointing number, only about 300, ever saw genuine active combat service due to the pervasive constraints of fuel scarcity, the lack of fully trained pilots, and the near-impossible maintenance demands. These precious jets were allocated to elite units, such as Jagdverband 44, JV-44, a hand-picked squadron composed exclusively of veteran Luftwaffe aces and commanded by the legendary General Adolf Galland, who desperately believed the jet represented the only possible remaining technological way to defeat the overwhelming, suffocating Allied air superiority. Tragically, by the time these jet units became even marginally operational, the war was already decisively lost on both the Eastern and Western fronts. The Me-262, while the most famous, was not the sole German jet aircraft in active development and use. The formidable rival Arado R-234 Blitz holds the distinct historical position as the world's first operational jet reconnaissance and bomber aircraft, utilizing the exact same Jumo 004 engines. The R-234 was primarily utilized for extremely high-speed photographic reconnaissance missions over the Allied invasion fronts, a role where its unprecedented speed made it practically immune to any attempted interception. This simultaneous deployment further and convincingly proved the immediate versatility of the jet engine and its capability to revolutionize not just the fighter role, but also critical non-fighter operational roles such as reconnaissance. The capture of the Me-262 aircraft and its extensive design documentation by Allied forces immediately following the cessation of hostilities provided a colossal, vital leap in aerodynamic research that would shape the future of flight. The jet's pioneering use of the swept wing, even if its initial application was somewhat accidental, was meticulously studied by both American and Soviet engineers. The captured data directly informed the development of the next generation of post-war American and Soviet jet fighters, leading directly to the iconic swept-wing designs that defined the subsequent Korean War era, such as the formidable F-86 Sabre and the opposing MiG-15. The Me-262's contribution ensured the permanent rejection of the straight-wing design for high-speed flight. The transition to jet engine technology also introduced entirely new, unprecedented operational hazards for pilots. The immense, searing heat signature of the jet exhaust and the high-pitched, distinctive whine of the engines were easily detectable by ground observers and early warning radar systems, particularly when the aircraft was operating at lower altitudes. Moreover, the extreme aerodynamic forces exerted on the pilot at speeds nearing the critical speed of sound required the rapid development of rudimentary, strengthened cockpit structures, better oxygen systems, and anti-G suits, fundamentally pushing the limits of both the material technology and human physiological endurance in high-speed flight. The psychological impact that the sudden, terrifying appearance of the Me-262 had on the Allied bomber crews was arguably as profound and debilitating as the actual physical damage it inflicted. For the very first time in the war, bomber crews felt they were facing a faster, more lethal enemy they literally could not outrun or escape. The enormous speed differential of the jet made effective evasive maneuvers nearly impossible, and the distinctive, thundering sound of the 30mm cannons was often the first and tragically the last warning the target crew received before catastrophic impact. This constant, pervasive, and overwhelming threat forced Allied High Command to dedicate significantly more combat resources than ever anticipated to protective fighter escort and aggressive anti-airfield suppression operations. The sophisticated armament developed specifically for the Me-262, particularly the devastating R-4M rockets, exerted a huge and lasting influence on post-war fighter armament doctrine globally. The R-4M, Rocket 4, Megagram was a simple, cheap, and tremendously effective air-to-air weapon. Fired in synchronized salvos of 24 rockets, they created a devastating high-explosive spread that could reliably destroy an entire heavy bomber with one successful pass, completely eliminating the need for the jet to get into dangerous close range. This fundamentally altered the tactical requirements for intercepting large, resilient enemy aircraft, pointing toward the future of guided missile technology. Despite the massive two-year German technological head start, Allied jet development accelerated at a phenomenal pace during the final years of the war. Britain's Gloucester Meteor entered limited service in July 1944, earning it the official distinction of being the first Allied operational jet fighter. While the initial models were slower than the Me-262 and used primarily for localized defensive patrols against V-1 flying bombs, its deployment successfully demonstrated the Allies' parallel technological capability and served as a crucial, functioning testbed for British engine technology that would later be shared with the US and prove influential in the design of the next-generation Korean war jets. The enduring legacy of the Me-262 is undeniably and tragically linked to the critical issue of timing and political will. Had Hitler been persuaded to heed the expert advice of his top design team and authorized the mass production of the Me-262 as a dedicated pure fighter interceptor 2 years earlier, as strongly requested by Messerschmitt and Galland, the jet might have significantly, perhaps decisively, altered the course of the air war over Europe, potentially denying the Allies the overwhelming air superiority that was absolutely crucial for the success of the D-Day invasion and the strategic bombing campaign that crippled German industry. The complex, sensitive nature of the jet's engine management proved so daunting and technically challenging that the German Luftwaffe was compelled to create a specific, dedicated training institution, the Lehrkommando 262, solely dedicated to teaching pilots the highly unique handling characteristics, the delicate throttle management required, and the unforgiving landing vulnerabilities of the new machine. The Luftwaffe mandated that only highly veteran pilots, often already celebrated, decorated aces be allowed to fly the jets, emphatically demonstrating that even with such a massive technological edge, the inherent complexity of the new revolutionary machines demanded an extremely high, specialized level of pilot skill and experience. The highly adaptable Me-262 was rapidly modified for specialized night combat, designated as the Me-262 B1A-U1, and equipped with an early, rudimentary form of airborne interception radar. While these specialized night fighters were deployed in very small numbers, they proved to be potent, difficult-to-detect threats against the massive British night bombing campaign, highlighting the crucial, inherent adaptability of the jet platform for all-weather, 24-hour operational roles, providing yet another clear, compelling glimpse into the inevitable multi-role future of the modern jet fighter. Following the final German defeat and surrender, the surviving operational Me-262 airframes, along with all the critical technical plans and the highly specialized Junkers and BMW jet engine development specialists, became immensely prized intellectual and physical prizes for the victorious Allied powers. The US immediately launched Operation Lusty to gather and exploit these assets. Captured Me-262s were exhaustively tested and analyzed at Wright Field, Ohio, and their design features immediately and profoundly influenced American high-speed research, contributing directly and heavily to the core design and rapid development of post-war jets like the ubiquitous F-86 Sabre. The technical blueprints and surviving Me-262 airframes, along with the Jumo 004 engine, were also urgently shipped to the Soviet Union, where they formed the critical initial basis for early Soviet jet design and propulsion studies. While the Soviets eventually migrated toward powerful, highly successful indigenous designs, the captured German technology played a crucial, indispensable bridging role, significantly accelerating Soviet jet development by several years and directly informing the fundamental architectural design that would eventually lead to the hugely successful and globally deployed MiG series of fighter aircraft, effectively launching the protracted aerial arms race of the Cold War. The decisive, fundamental aerodynamic principle that was initially stumbled upon and then successfully exploited by the Me-262, the incorporation of the swept wing, was later fully and conclusively proven by the detailed analysis of captured German high-speed data to be absolutely essential for strategically minimizing the severe aerodynamic drag, known at the time as the Mach effect or compressibility drag, that conventional, older, straight-wing aircraft disastrously experienced when flying near the speed of sound, which resulted in fatal structural buffeting and loss of control. This vital, final discovery, confirmed by post-war wind tunnel testing, permanently and profoundly solidified the Me-262's lasting technical legacy. It ensured that all subsequent generations of transonic and supersonic aircraft would be compelled to mandatorily incorporate either advanced swept-wing or distinctive delta-wing designs, as straight wings simply could not perform effectively at the speeds jets could achieve. The Me-262's wing design cemented its role as the foundation of modern high-speed aviation, making the earlier piston-era designs a permanent relic of history. The combat effectiveness of the Me-262, despite its brutally brief operational lifespan and its severe crippling by catastrophic fuel and material logistics, achieved a staggering and often debated kill-to-loss ratio that typically ranged around 4:1. Conservative Allied estimates suggest over 100 Allied kills for just 25 German combat losses, though German claims were higher. This incredible, statistically verifiable ratio provided the final, undeniable proof that confirmed the inherent, decisive combat superiority of jet propulsion over the older, technologically limited piston engine in the definitive fighter role. The Me-262's operational success effectively and permanently closed the chapter on the propeller-driven fighter era, demonstrating that no amount of armor, horsepower, or pilot skill in a conventional aircraft could overcome the sheer speed and altitude advantage of the jet. The age of the jet was now the only military reality, rendering all previous fighter designs technologically obsolete and demanding that the world's air forces immediately pivot their entire research and development efforts toward turbojet technology. The Messerschmitt Me-262. Schwalbe, though ultimately and tragically incapable of saving the collapsing German Third Reich, due to political mismanagement and crippling resource shortages, stands without peer as the single most important and definitive transitionary aircraft in the entire history of modern aviation. Its historical significance is defined by a trinity of achievements. It was the first operational jet fighter in history, the first aircraft to utilize the mass-producible axial-flow jet engine, the architecture still used today, and the first to employ devastating, unguided air-to-air rockets as a primary weapon system against massed formations. The jet's revolutionary technological breakthroughs, its tragic political mismanagement, and its profound ultimate strategic impact all collectively ensured that the indelible, technological, and strategic mark of the dawn of the jet age was unequivocally etched by the revolutionary speed and unique, high-pitched scream of the Schwalbe. Its brief existence fundamentally changed global aerial warfare forever.